Hello everyone, my name is Lutfi, and in this video we are going to resume our lectures about biology, and we are going to continue from acids and bases, and these are the main subjects for this video. And so without any further ado, let's get started with our video. So let's start with the basics. Okay, so occasionally a hydrogen atom participates in a hydrogen bond between two water molecules, and it shifts from one molecule to another. And when this happens, the hydrogen atom leaves its one electron and it becomes a H plus ion, as shown in this picture. And as you should remember from our last videos, when hydrogen becomes an H plus ion, it is usually not usually only a single proton. Okay, and so the H plus okay, sorry, from the beginning. And so the hydrogen atom has shifted and has turned one H2O molecule into hydroxide and hydroxide ion, or OH minus, and another water molecule to a hydronium ion, or H3O. Okay, and you can see those in the picture below as well. And have in mind that H plus ions do not exist by themselves, but in aqueous environments, okay, it always exists in an hydronium structure. Okay, and have in mind that this reaction is reversible, as shown by the double arrow. And in the equilibrium point, only 1 out of 554 molecules of water dissociate. Okay, so they are very rare, this dissociation of water molecules, and as I told you, they are reversible, but they are very important for the chemistry of life. Okay, and have in mind that H plus and OH minus ions are very reactive, and so changes in the concentrations can drastically affect a cell's proteome and other complex molecules of a cell. And I should have told you in the beginning that proteome means all the proteins that exist inside a cell. And as we have seen, the concentration of H plus and OH minus ions are equal in water. Okay, but by adding some molecules named acids and bases to water, we can disrupt this balance between H plus and OH minus ions. Okay, and I'm sure you know this, but biologists use something called a pH scale to describe how acidic or basic a solution is. Okay, and this is an example of this pH scale. Okay, and as you can see, some of the substances or things that we use every day are shown by this pH scale. Okay, so it's good to pause this video and just read it once. Okay, so the basics are of acids and bases are over, and from this moment on we are going to get more into detail with acids and bases. Okay, so buckle up. Okay, so when we describe acids in water, they donate additional H plus ions to the solution. Okay, so when we dissolve them in water, they donate H plus ions. Okay, and so when we want to describe an acid, we say that they are substances that increase the H plus ions concentration in a solution. Okay, so take for example hydrogen chloride, or HCl, as shown in this picture, which is a very powerful acid, and when it is added to water it dissociates into H plus ions and Cl minus ions. Okay, and as you might have guessed, a substance that reduces the higher H plus ion concentration is a base. Okay, so some bases reduce the H plus concentration by absorbing the H plus ions in the solution. Okay, so an example would be ammonia. Okay, which it binds to or binds or absorbs the H plus ions, which are dissolved in the solution, okay, for example water, and it forms ammonium. Okay, ammonium, okay, so ammonia plus H plus. Okay, and have in mind that ammonia is NH4, no, NH3, okay, plus a hydrogen ion, it equals ammonium, okay, or NH4. Okay, so, and as you might have guessed, ammonium does not affect the pH value of a solution. Okay, but some bases reduce the H plus concentration indirectly, and they dissociate and form OH minus ions, and thus H plus and OH minus ions bind together and form H2O, or water molecules. Okay, which as you know water is pH neutral. Okay, so one example would be sodium hydroxide, okay, or hydroxide, I think. Okay, which is a very strong base, and it dissociates into sodium cations, or Na plus, and hydroxide. Okay, which is OH minus. Okay, and so you know the rest. H plus ions that are in the solution come and bind to OH minus and form water, which is pH neutral. Okay, so in either case the base reduces the concentration of H plus inside the solution. Okay, so solutions that have a higher concentration of OH minus than H plus ions are called basic solutions, okay, or bases. And solutions which the H plus and OH minus concentrations are the same are said to be neutral. For example, water is one of these examples, which as we said, H plus and OH minus concentrations are equal. Okay, and always know this, that whenever a base and an acid react, their products are water and a kind of salt. So for example, when hydrogen chloride and sodium hydroxide react, their products are H2O, or water, and NaCl, okay, which is table salt. And a fun fact, I think, is that whenever you have ran out of salt in your kitchen, you can and if you have these two molecules lying around for any reason, you can make your own salt solution, okay, because water is created as well. And you might have asked yourself, based on what do I say that one acid is weak or strong? Okay, so let's learn with an example. So when HCl, which is a strong acid, dissolves in water, okay, it dissociates completely. and the same is true for strong bases. But when weak acids or bases are dissolved in water, they don't dissociate in water that well. Okay, so in conclusion, the stronger it is, the better it dissolves. And here is a table that shows some substances, okay, that are acids and bases and their strength. Okay, and so that was all for this video. I hope you enjoyed it, and if you did, please write a comment and hit that like button. And so until the next time or next video, happy learnings to you all.